Alright, question number 16. Maths is coming. Brace yourselves. We've got two potentials here. The initial potential, which I guess we could describe as V1. We're given as 45 volts. And that is at distance, and we'll call it R1. Let's give it as R in the question, but we're going to be looking at two distances, so just to make it very clear, we'll use R1 as our distance. We then go to a situation where we have a new potential V2, which is 50 volts. Our potential has increased, and we've done that by moving the charges together, or by moving towards our charge rather, because we're only looking at one charge because we're thinking about potential. We're decreasing our distance by 1.5 meters, so we've got this new distance R2, and we know that R2 is just the first distance R1, whoops, minus that should be 1.5 meters. So that's our setup. We now got to work out what the value of R is going to be, so it's going to need a little bit of substitution to get it in. Each stage is fairly straightforward, there's just a fair number of them. So we're going to stick the numbers into the equation first of all. We know that V is KQ over R. So we know that 45 volts for our first one is going to be K, remember K is 1 over 4 pi epsilon naught, KQ over R1. So that's our first situation. Our second situation is going to involve V2. But before we do that, we're just going to work out what this charge is going to be, because of course we don't know what the charge of this object is. We're not told. If we were, it would make things a lot easier. But let's just express what the charge is going to be in terms of these things. So if I multiply both sides by R1, divide both sides by K, sorry about the lame paper, we're going to end up with a term for Q. We're going to find that Q is 45 R1 over K.